So what we want to be able to do is predict what type of reaction is going to occur, and then from that, figure out what products are going to form. So if we follow along, this is your study guide for this unit. And in number 14, what we have here is potassium iodide and fluorine. So really what we have to do is we have to think about, okay, what are our reactants? So we have potassium iodide, which is a compound, and we have fluorine, which is an element. So if we have a compound and an element, this is going to be a single displacement reaction. So in a single displacement reaction, we had the idea of you had A plus BC goes to A B plus C. So either way, A is going to come out and replace one of these two. And that's all based on the oxidation numbers. So if A is a cation, it replaces a cation. If A is an anion, it replaces the anion. So if we look at potassium iodide and fluorine. So potassium is K and iodide is I. And then fluorine would be F2. We know that it's diatomic. And so fluorine is an anion, so it's going to replace the iodine. So then what you have to do is you have to look at your activity series on this paper right here, and you have to make sure that the A, the element, is higher on that activity series. So if we look, here's fluorine and here's iodine. So fluorine is higher, so yes, it can replace the iodine. This is the only one in the single displacement reactions that we have to use the activity series, and only for single displacement reactions do you have to use the activity series. So it is going to replace the iodine because we said it's higher on that activity series, so we're going to form Kf plus I2. And we know that potassium is a 1 plus and F is a 1 minus. That's why we only have one of each of those. And iodine is also diatomic, so we have to have the 2 there because now it is by itself. So then you just go back through and you balance your equation. All right, looking at the next one, we have magnesium and water. So magnesium is an element, water is a compound. So this is also going to be a single displacement reaction. And so magnesium is Mg, water is H2O. Magnesium is a cation, and so it will replace the cation in here, so that's going to be hydrogen. So you have to look at the activity series, and here is magnesium and here's hydrogen. So yes, magnesium is higher than hydrogen, so it can replace the hydrogen, and so this will form magnesium oxide plus hydrogen gas. Magnesium is a 2 plus and oxygen is a 2 minus, so that would be our chemical formula, just MgO. And then you have hydrogen is diatomic, so this equation is read balanced. Looking at our next one, we have hydrogen and nitrogen. So these are 2 elements. So this is going to be a synthesis reaction because you just have the 2 elements. So you have hydrogen, which is diatomic, so that's H2, and you have nitrogen, which is also diatomic, so that's N2. So they are simply going to bond together. So when you bond them together, you have hydrogen, which is a 1 plus, and nitrogen is a 3 minus. So we're going to need 3 hydrogens here to make this chemical formula work. However, of course, we can see it's not balanced, so we have to put a 3 here and a 2 right there. Now we have a balanced chemical equation. Our next one that we have, aluminum oxide, there's just one reactant. So whenever there's just one reactant, we know that it's going to be a decomposition reaction. And aluminum oxide is Al2O3 because aluminum is a 3 plus and oxygen is a 2 minus. And it says it's endothermic, so we have to add in some energy to this. And then we are going to break it apart because that's what happens in a decomposition reaction. So we're going to form aluminum plus oxygen. Now notice aluminum does not carry that 2 with it because it's not diatomic. So we would just leave it like that. And oxygen is diatomic, so that does need the 2. And so you just go back and balance the equation. So I'm going to put a 2 here, a 4 there, and a 3 right there. Then our last one on this side, we've got propane and oxygen. So propane is an alkane. So whenever you have those organic compounds, we know it has to be a combustion reaction. We also see that it contains oxygen and it's exothermic, so we give off energy. Those are all characteristics of a combustion reaction. So if you look at propane, prop means 3, and ane means that's an alkane, so it's plus 2 times 2, or sorry, times 2 plus 2. So it's C3H8 plus oxygen, which is O2, and we always form the same two products, carbon dioxide and water. So then the next thing to do is just go back and balance the equation. So we have a 4 here and a 3 there, and then we have 6 oxygens here plus the 4 over there, so that gives us 10. So there's our balanced equation. Now on the other side, we've got a couple more. So we've got lithium bromide and potassium sulfide. So lithium bromide is a compound and potassium sulfite is a compound. So this is going to be a double displacement reaction. And in a double displacement reaction, you have 2 compounds. And so with the 2 compounds, we have LiBr and potassium sulfate. So potassium sulfite would be written as K2S. The ITE tells you that it's a polyatomic ion. So this is SO3, right? So this would be our 2 reactants, and then we need to check, remember, your solubility chart to make sure that you have 2 aqueous reactants. So if we look at lithium bromide, it says ions that form soluble compounds, so group 1 ions, so lithium. So this is aqueous. And then we have potassium sulfite, and that's the same thing. So still in group 1, so that is going to be aqueous. So then we need to form an aqueous and a solid. So remember, these are going to switch places. So the cation of the one goes with the anion of the other. So we would form Li2SO3, and then we would form KBr. However, because lithium and potassium are both all aqueous, these would never form. This is no reaction because these are going to form 2 aqueous products, and you must always form an aqueous and a solid product. So that does not work. You have to have 2 aqueous reactants, but you have to have an aqueous and a solid product in order for a double displacement reaction to work. So let's look at the next one. We have barium hydroxide and zinc chlorate. So barium hydroxide is BaOH2, and then zinc chlorate is Zn, and then ClO3 too, sorry. Then when we check these out, because this is also a double displacement, because we have 2 compounds again, so we look at barium hydroxide. So hydroxide are generally insoluble, but if we look at the exception, barium is right here. So that means that it will dissolve, because this is barium hydroxide is an exception to that. So this is going to be aqueous. And then we have zinc chlorate, and if we look right here is chlorate, and it is soluble, so we know that this is aqueous. And so once again, the cation of the one goes with the anion of the other. So this is my cation, this is my anion, so barium chlorate would combine together. And then the zinc and the hydroxide would go together. And then we have to also make sure that we form an aqueous and a solid. And so we know chlorates, we just looked at this sheet right here. And chlorate will be aqueous. And then if we look at hydroxide, hydroxide is insoluble, so that will be your solid. So this reaction works. Then our last one on here, we have sodium chloride and silver fluoride. So sodium chloride is NaCl, silver fluoride is AgF. And so we want to make sure, this is also a double displacement reaction, because you have 2 compounds. So our sodium chloride we know is aqueous because everything with group 1 is going to be aqueous. And then silver fluoride. Here's our halides. So fluoride would also count with that fluorine, chlorine, bromine, iodine. And if we look at the exception, right here is the exception. Silver is combined with it, which means that this is actually going to be a solid. So once again, we will have no reaction because both of our reactants must be aqueous to begin with. So when you're trying to figure out what products are going to form, the first thing to do is figure out what type of reaction you're going to have. Once you know the type of reaction, then you'll be able to predict what products are going to form, if any. Remember, there are only rules for single displacement and double displacement. Combustion, synthesis, and decomposition do not have any specific rules that you have to look at. But for for double displacement, you have to look at this, and for single displacement, you have to look at your activity series.